In this video, you will learn about foundation models, which, as the name suggests, provide a foundation for generative AI models. Specifically, we start by providing a definition for foundation models and explaining what they are. Then, we will talk about platforms that provide different kinds of foundation models with a focus on Vertex AI's model garden, and end the video by discussing different types of foundation models. Now, what are foundation models? Let's ask Bart to help us answer the question. It provides three different drafts. Foundation models are large pre-trained neural networks that can be fine-tuned for a variety of tasks such as natural language processing, computer vision, and speech recognition. Foundation models are large language models trained on massive datasets that can be fine-tuned for a variety of downstream tasks such as translation, question answering, and summarization. Foundation models are large pre-trained machine learning models that can be adapted to a wide range of tasks such as natural language processing, computer vision, and robotics. So, foundation models are large AI models that can be adapted to a wide range of tasks and can generate high quality output. Even though AI models aren't brand new to us, there's something quite different about these foundation models. They come equipped with several key characteristics that set them apart, marking a significant shift from the AI models we've seen in earlier generations. Foundation models aren't limited to a single task, they're multitask. A single foundation model can tackle a wide range of tasks right out of the box, such as summarization, question answering, or classification. They can handle various modalities of data types, including images, text, code, and much more. With minimal or no training at all, foundation models can work well out of the box. They can also be tailored for specific use cases, using only a handful of example data. Because they are typically trained on vast amounts of diverse data, these models can learn general patterns and representations, which can then be applied across various domains and tasks. Before now, foundation models were difficult to access, required specialized machine learning skills and compute resources to use in production. But with the recent wave of advancements in generative AI, things are changing dramatically. For example, take Vertex AI, a fully managed machine learning platform available on Google Cloud. If you are already familiar with Google Cloud's tools, you already know that Vertex AI enables you to access, build, experiment, deploy, and manage different machine learning models. Things like traditional data science, machine learning, MLOps, or simply creating an AI driven application. Vertex AI is equipped to support all such workloads. That's pretty cool and all. But this is where things start to get really interesting. Recently, Google Cloud announced two major tools which enable us to do even more: Model Garden and Generative AI Studio. These tools make foundation models available to a much broader audience, even without much experience with coding and ML development. The last section of this course is dedicated to introducing Google Cloud Gen AI tools, and we will talk more about Generative AI Studio in that section. So, in this video, let's only focus on Model Garden. What is exactly Vertex AI Model Garden? It's a single place to explore and interact with both Google's industry leading models as well as popular open source models, all with Google Cloud's enterprise MLOps tooling support built in. It houses both traditional machine learning models and foundational models for generative AI applications. Inside Model Garden, you'll find a range of models from Google Cloud, Google Research, and various external sources, accommodating a variety of data formats. So, this is what inside Vertex AI's Model Garden looks like. With many different enterprise ready models at your disposal, Model Garden enables you to select the most suitable model depending on your use case, your expertise in ML, and your available budget. Please keep in mind, we are using Vertex AI's Model Garden as an example of a platform that Google Cloud provides for different generative AI and other machine learning tools and APIs. There are other companies which have their own versions of Model Garden as well. For example, Amazon SageMaker, IBM Watson Assistant, NVIDIA Clara, Dataiku AI, OpenAI ChatGPT API, Microsoft Azure's machine learning, Data Robot AI, and Databricks Lakehouse platform all provide tools and APIs for both traditional machine learning models and generative AI foundation models. There are different types of foundation models, including text generation and summarization, chat and dialogue, code generation and completion, image generation and modification, and embeddings. Now, let's have a deeper look into each of them. Text models. These models help you perform natural language tasks with zero or few shot prompting. They can do tasks like summarization, entity and information extraction, idea generation, and much more. For instance, a journalist could use text models for summarization of large articles or reports. An academic researcher could extract specific entities of information from a massive corpus of papers. Or in a brainstorming session, an entrepreneur might use the model to generate new ideas or perspectives. As mentioned earlier, these models work effectively right out of the box. However, if you desire the model to follow certain specifications, you can provide structured examples to guide its responses. This allows for a tailored experience that aligns with your specific needs and objectives. Next, let's focus on dialogue. These models are also text based, but they've been fine tuned to hold a natural conversation. Dialogue models allow you to engage in multiple turn conversations, keeping the context throughout the interaction. Consider a scenario in a customer support center. An AI chatbot powered by these dialogue models can assist customers, remembering the previous turn of the conversation and providing context aware responses. It can answer questions, summarize information, or even guide users through complex procedures, all while being fine tuned to your specific domain. These models can help you build powerful tools that greatly enhance the user experience, whether deployed on a browser, a mobile app, or other digital interfaces. Moving on to code completion and generation. These models act as your supercharged coding assistant. You can give a natural language prompt to describe a piece of code you want written, or you can use the model to autocomplete a piece of code. There are even extensions for IDEs that can take a partial code snippet as input and then provide the likely continuation. Imagine you're working on a complex software project. It can help eliminate the tedious aspects of coding, even provide help with debugging your code, allowing you as a developer to focus more on the creative problem solving and less on syntax or routine code. And now let's dive into image generation. These models allow you to generate and edit images according to your specifications. In addition, you can utilize these models for media related tasks, such as classification, object detection, and more. Plus, such models typically incorporate content moderation mechanisms to ensure responsible AI safety practices. Imagine you're building an e commerce platform. A model for object detection can automatically tag items in the product images, while an image generation model can create new product images based on descriptions. The content moderation feature would ensure all user generated content aligns with your platform's policy, enhancing user experience. Last but definitely not least, let's talk about embeddings, which might sound a little complex, but it's actually a really cool concept. So let me explain it for you. Imagine you have a huge basket of fruits and you want to sort them out. You could sort them by color, size, weight, or even taste. Similarly, in the world of data, we often need to sort or categorize things. But the things we're dealing with are words or phrases, not fruits. That's where the embeddings come in. They are like a unique ID card for every word or phrase, but instead of a card, it's a list of numbers, which we call a vector. This list of numbers captures the essence of that word or phrase, its meaning, its context, and its relationships with other words. With embeddings, we can make sense of unstructured data like a long book or a Twitter feed, and use this understanding to do things like powering recommendation engines or targeting advertisements more effectively. For example, consider the realm of e commerce. An embedding model can be used to power recommendation engines, matching users with the products they are most likely to be interested in, based on their browsing history. Or in digital marketing, these models can enhance ad targeting systems, enabling highly personalized advertising. They can also be used for complex classification tasks, search functionality, and many other applications. So, in conclusion, foundation models represent a significant leap forward in AI technology. They offer a powerful, adaptable base that can be used for a wide range of tasks right out of the box. With platforms like Vertex AI's Model Garden, these tools are more accessible than ever before, putting advanced AI capabilities into the hands of a much wider population of users. From natural language tasks to multi turn dialogue, code implementation, image generation and modification, and semantic information extraction, the potential applications of these models are vast. Whether it's enhancing customer service with AI chatbots, assisting developers with auto generated code, or powering recommendation engines, foundation models are shaping the future of AI. With foundation models and the power of generative AI, we're not just predicting the future, we're building it. In the next video, we see some of the amazing applications that different types of generative AI models offer.